Hey everybody, welcome to part 2 of my partitioning series. This series is also called dividing line segments. So partitioning and dividing line segments are used interchangeably. I have a problem already written up for us, so I'm going to read that. So where is P on directed segment QR if Q is at 3, 5, R is at -5, -7, and the ratio of QP to QR is 3 to 4. It's a lot of information all in that one little section. Let me fix a couple of things. So the first thing that you should do, even before you draw your dash diagram, is to graph the picture and label the points. So it's really important that Q has a Q next to it and that R has an R next to it. That's going to help you whenever you're trying to figure out what your final answer is. The next thing that's extremely important is because it says directed line segment, a directed line segment, the order matters. So because Q comes before R, the way they wrote that, they chose to write it QR. That literally means that Q is the starting point and R is the end point. So I also like to label that. So I know that this is where I'm going to start and this is where I'm going to end. And then before I get started, I also like to draw out my dash diagram. So the first video that I did when we used ratios and wrote them in different ways and drew out all of our dashes, if you need a refresher on how to do that, you can go back and watch that video. So right here, this is the information I'm going to use for my dash diagram. And it's always good to decide whether you're dealing with a part-to-part ratio or a part-to-whole ratio. Because of the way this is worded, and I know that QR is the whole segment, whatever letters they use for the directed segment, that's your whole segment. So QR is the whole thing. So I know that this is going to be a part to whole ratio. So I'm going to draw out my dash diagram given that the whole thing is 4 sections long. So here's my dash diagram. And I've got 1, 2, 3, 4 dashes. Now, just because I already graphed it and I can see that the Q is actually, the starting point is actually on the right and the ending point is on the left, I like to make my dash diagram mirror that. So I'm going to put Q over here, I'm going to put R over here. You would still be able to use it if you had them in the wrong order. It just wouldn't look exactly how it was matched up here. Then, because it says that Q to P is 3 sections, I'm going to make sure that from Q toward R, from Q to P, is after I cross over 1, 2, 3 sections. So I know that right here is actually where P needs to go. And just by doing that and not doing any other work, you can already start to estimate where your answer is going to be. Especially since I set it up so that the order from Q to R was from right to left. I could actually almost enlarge this, scale it up, and place it here diagonally, and kind of see that I'm going to cross over 1, 2, 3 sections and place P, 1 of those sections from R and 3 of those sections from Q. So I know that my final answer really should end up somewhere around here. To find that exact answer, the first step, if you're going to do this using graphing, is to draw out your slope. So I'm going to draw all the way up and then all the way over. So you'll have to excuse the fact that I don't have an actual coordinate plane with grids and everything. This is much easier to do when you're at home and you're just using graph paper. You'll be able to get the answer much more easily, still with the same steps. So here I can check this distance. I would count it. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12 units from here to here. And then this is 5, 6, 7, 8 units. And that's step 1. And the next step, actually a quick detour. If you can tell that your slope is going to be able to be reduced and you want to kind of decide whether it's going to be a hard problem or an easy problem, if the slope is something like this where you can reduce it, typically it's an easier problem and you should get an integer answer. Remember, an integer is just a whole number, but it could be positive or negative. I'll make another video in the next one where we deal with either decimals or fractions and mixed numbers. So after that, my next step in order to figure out where my final answer is out of these two segments that we just drew, one of them connects to the starting point. So sometimes you'll use the vertical section, sometimes you'll use the horizontal section. It depends on which one connects to the starting point. So I can see that the horizontal section connects to the starting point, so that's the number I want to focus on. So what you're going to do is you're going to take that distance of 8 and you're going to multiply it by the part to whole ratio that you're working with. So in this case, we didn't have to do any extra work to get the part to whole ratio, they just gave it to us. Sometimes they won't be as friendly and you'll have to use your dash diagram to come up with the part to whole ratio. But my part to whole ratio is going to go from Q to P, and that's 3 sections, compared to the whole thing, which is 4 sections. So you're going to take your distance and you're going to multiply it by your part to whole ratio. So if I do that, I'm going to end up with 8 times 3, which is 24, divided by 4, which is 6. What that tells me is I need to go back to my starting point, and instead of walking over the entire 8 units, I'm only going to walk over 6 units. So this would be 1, 2, 3, 4, 5, 6. And I would land right here. Then what you want to do is you want to draw a line that goes straight down from that point that intersects with your segment. So I'm going to draw that down. And that point that you end up with, the point where that intersects with your original segment, is going to be your answer. So this value here is going to be P. And you can look at the coordinate plane to figure out where you're at. So that's at -3, comma, -4. You can also double check your answer to see that the proportions look like they correspond with your dash diagram. It has a larger section and a smaller section, it has a larger section and a smaller section. So you can kind of estimate that your answer is correct based on that. Some students don't want to draw anything and they don't want to think about this using kind of number sense, and they'd rather just have a formula. So I do have a formula that you can use. And I'll work it out, kind of show you that you get the same thing. You're still going to need to do your dash diagram even if you use the formula. You're still going to use this part to whole ratio when you use the formula. So for your formula, you need to label x1, y1 as the start point, and x2, y2 as the end point. And you know which one's the start point and the end point because of the order of the letters in the directed segment. So Q is going to be x1, y1, and R is going to be x2, y2. And then you're going to follow the formula x1 plus the part over whole ratio multiplied by x2 minus x1. And the same thing for the y's. y1 plus the part to whole ratio multiplied by y2 minus y1. And make sure you follow the order of operations. So in the order of operations, you're going to have to multiply the fraction with this number first, and then add that answer to your first term. So if I were to work all that out, given the information we started with, x1 is 3. My part to whole ratio, you're still going to have to do your dash diagram so you can get your part to whole ratio. That's 3 over 4. And then I can do x2 minus x1. And the same thing for the y's. So y1 plus the part to whole ratio times y2 minus y1. And if I continue to work that out, I'm going to get 3 plus 3 over 4 times negative 8, which is 3 plus negative 6, which is actually just 3 minus 6, which gives you negative 3, which was the coordinate that we got for x. And the same thing here. So it'll be 5 plus 3 over 4 times negative 12. It's going to be 5 plus 3 over 4 times negative 12 is negative 9. And 5 minus 9 is just negative 4. So regardless of which way you try to solve it, whether you graph it out and use your distance times the part to whole ratio and then graph back your answer, or you just use the formula, they'll both work, and good luck.